In the previous part, we learned how to detect and quantify correlation between two continuous variables. However, what if your dataset doesn't have continuous variables? Now, don't worry, because in this part, we will actually explore correlation between non-continuous variables or categorical variables. But of course, first of all, what is a categorical variable? Now, instead of giving you a very general and thus vague definition, let's just look at two example questions that contain categorical variables. Are married people more likely to be employed? Now, this question involves two categorical variables. One is being married or not, and the other one is being employed or not. So just two outcomes for each variable. Another example would be, do smokers have more chance to develop lung cancer? Again, you can be a smoker or not, and you can either develop lung cancer or not. Again, two outcomes for each variable. However, keep in mind that a categorical variable can also have more outcomes. For instance, political affiliation. At least in most countries, you have many different parties to be affiliated to. Now, the only way to answer these questions is to look at the data and perform sound statistics in order to see whether there is any correlation between these two variables. In the case of categorical variables, there are two tools that allow you to do this, namely the contingency table and the chi-square test. Now, additionally, there is of course also the visual approach, which we will also cover. And to learn about these tools and how they work, let's look at a very concrete, albeit a bit frivolous example. Is there a correlation between pet preference and gender? Meaning, do men and women have the same level of preference between cats and dogs? Now, to answer this question, there are two things that we need. First, we need a null hypothesis, and second, we need a suitable dataset. Now, the null hypothesis will be that there is no correlation between these two variables. Or in other words, each gender has an equal level of preference. Let's say, for instance, that 60% of both men and women prefer cats over dogs. Now, the dataset that we'll be working with to answer this question is collected by asking both individual men and women what their preferred pet animal is. And then all of these results can be collected and put in a table like this. Here, for instance, in this cell, we fill in the number of men that prefer cats over dogs. Whereas here, we fill in the number of men that preferred dogs over cats. And the same for women. And additionally to these observed values, we also add the row sums and the column sums to this table. In the rows, this gives us the total amount of men that we questioned and the total amount of women that we questioned. And in the column sums, we then get the total amount of people that preferred cats and the total amount of people that preferred dogs, irregardless of their gender. Now, these summed values will be very useful once we start looking at the actual tests, a couple of slides down the road. Now, of course, I didn't go out and collect this data myself. Instead, what we will do is we will simulate these data sets in such a way that we can fine-tune its correlation. And by doing so, in essence, we capture all of the possible scenarios that we can explore. So how do we generate such a data set? The first step is to randomly divide 500 samples in either male or female. Now, this will be a random division, which will be roughly 50-50. But of course, we can deviate a little bit from that, just to simulate a realistic data set. Now, in the second step, for each of these two categories, we set a probability of preference of cats versus dogs. If we put these probabilities equal to each other, then there is no correlation between pet preference and gender. However, if we do put them differently, then there is a correlation. And in this way, we can fine-tune our dataset to have a large correlation, a small correlation, or no correlation at all. And in this way, we can capture all of these scenarios. And then we can use these probabilities to assign to each member of both male and female a specific preference according to their corresponding probabilities. And in this way, we get a very realistic dataset that might capture this correlation. Now, generating this data and collecting all of this data in a pandas data frame, we get the following results. Now, in this specific example, we generated our dataset in such a way that 70% of men preferred cats over dogs and only 60% of women preferred cats over dogs. And because these preferences are slightly different, we expect there to be a slightly correlation between pet preference and gender. Or in other words, this small correlation means that if we have the information about whether a person is a man or a woman, we also have some information about its pet preference. For instance, in this example, if we know it is a man, then we know that the likelihood that this person prefers cats over dogs is slightly higher than if this person would be a woman. But remember, of course, that correlation always goes both ways. In this example, of course, if we are given the information that a random person prefers cats over dogs, then we know that this person is slightly more likely to be a man than it would be a woman. Now, this difference in preference can be seen in this table that we have, which is called the contingency table, containing all of our data from our dataset in one place. We see that if we take the ratio of likes cats for males over the total, then we get roughly 75%, which is in line of this 70% preference that we set up front. However, if we take the same ratio of likes cats over the total for females, then we get roughly 60%. So this ratio difference between male and female is what the correlation is all about. Now, the same information can of course be abstracted from these visual representations. Here we have a bar plot for both males and females, and on the x-axis we have likes cats and likes dogs. Likes cats in blue and likes dogs in green. Now the y-axis is simply the number of people that answered with likes cats or likes dogs. So then the difference in preference between males and females can be seen by how much larger the blue bar is compared to the green bar. In our example, the case of males, we see that the blue bar is more than twice as high as the green bar, so a large preference of cats over dogs. Whereas for the female case, we see that the blue bar is less than twice as large as the green bar, so less of a preference of cats over dogs. Of course, these are just some spot checks, computing these ratios, and some visual inspections, looking at these graphs. But how do we now quantify this result? And additionally, how can we be certain that the results from this sample are indicative for a population at large? And that is, of course, where statistical testing comes in. Of course, what we need to do is to quantify these results. But that will be for the next lesson. To end this lesson, we will dive into the code and see how we can actually generate this contingency table and the underlying data sets. So let's dive into the code. And in this cell, all the lines that are needed to generate these data sets, which we can fine-tune for correlation and making the contingency table, are all included in only these lines of code. So let's go through them. The first step is to define the number of individuals, which will be the number of data points in our entire dataset. In our case, we pick 500. Then in the second step, we want to divide this group of 500 individuals into two categories, male and female. And we want to do so in a somewhat realistic way, namely such that we don't have exactly as many males as females, because in realistic scenarios, this will also not be the case. To do so, we generate this Python array by doing the following. We do numpy.random.choice, which means that we are going to pick numbers at random from a given Python array. Now the given Python array here will be 0 and 1, meaning we only get to pick between the value 0 and the value 1, indicating our two categories, of course. And the number of picks that we will do is of course 500. Now this means that we get a genders array with zeros and ones, which are roughly divided 50-50, but not exactly divided 50-50. And then comes the beautiful part of our simulation. Here we want to create a new Python array, which will be called preferences, which contains the preference of pet animal for each individual in our dataset. Now we need to make sure that the overall preference of males and females might be different. And that is what we will do in this for loop. Now in this for loop, we iterate over the Python array genders, which remember we just created, and it just indicates for each individual in our dataset whether it is a male or a female, so either 0 or 1. Now, if a specific element is 0, then we know that this individual is a male. And now we are going to assign this male a preference of either cats or dogs. Now, this preference, of course, we will need to do so randomly. But this random number that we generate, either a 0 for cats or a 1 for dogs, needs to be generated from a distribution that is in line with the probabilities that we assign it to. So what do we do? So the ith element in preference will be equal to a random number. Now this random number is again a random number that we choose from a specific Python array. In this case, again, the array 0, 1. So we again choose either 0 or we choose 1. 0 for this person to prefer cats and 1 for this person to prefer dogs. However, what we can do in this choice function is to provide explicit probabilities for both of these two elements. In this case, for the first element, we give it a probability of 0.7, so 70% that we choose a 0 and 30% that we choose a 1. And this, of course, reflects the average preference level of cats over dogs for males. So what this line does is that it generates a number, either 0 or 1, according to these probabilities. And then we assign this number to the ith element in our preference Python array. Now, if of course our gender is not 0, meaning that it is 1, corresponding to a female, then we do the same, but in this case, our preference probabilities will be different. In this specific case, we set a probability of 60% of choosing 0 and 40% of choosing 1. Now, these probabilities indicate that on average, 60% of women will choose 0 or cats, whereas only 40% of women will choose 1 or dogs. Now, because these two probability distributions for males and females are different from each other, means that there will be a correlation between this pet preference and the gender of the individual. Of course, if we want no such correlation, then we just set it so that we have 70-30 split also for women. Now, of course, we want to have a little bit of correlation, so we just put them the same. Just make sure that adding these two numbers up will give 1. This is the case for male, and this is the case for female. And going through this for loop, we then generated a preference Python array that contains either zeros or ones according to whether this individual, male or female, prefers dogs or cats. The next step will be, of course, to make our contingency table, meaning to count up the number of males that liked cats, the number of males that liked dogs, the number of females that liked cats, and the number of females that liked dogs. Now, because both of our two arrays, both genders and preferences, are binary Python arrays, so either 0 or 1s, what we can do is we can just sum over these arrays, and this will give us the total number of correspondence that gave this answer. For instance, the number of males that preferred cats over dogs is simply the sum of these two arrays, where we have gender equal to 0, so it needs to be a male, and the preference needs to be 0, because we said 0 is likes cats. And taking this sum, we simply get the number of males that preferred cats over dogs. Now, the same can be done for males that prefer dogs, females that prefer cats, and females that prefer dogs. Here we take the sum where genders is equal to 1, so a female, and preferences is also equal to 1, a dog. And this gives us 4 numbers. And these numbers we can now use to populate our contingency table. We define our contingency table as a Python array, a 2-dimensional Python array. On the first row, we have the male cats and male dogs. Of course, the males that prefer cats and the males that prefer dogs, and the same for females on the second row. Now, in order to also get these row sums and these column sums, we want to take this Python array and turn it into a data frame. So if we scroll down past the plotting part of this code cell, then we see that we do this in these 4 lines. So first of all, our contingency table df, so a data frame, is pandas.dataframe, We give it our two-dimensional Python array and we give it some names. So the columns will be likes cats and like dogs, and the index will be male and female. And then these two lines of code are there to make the sum rows and the column rows. And to do so, we will use lambda functions. Now again, I will not go into this in detail here, which I will leave for the corresponding video on the Code for Data Science YouTube channel. Now if we do this and we run this cell and we scroll down past the visualizations, then we get indeed this contingency table, the same as the one that we got in our slides. So from the 500 individuals, we had 171 males that preferred cats and 79 males that preferred dogs. We had 150 females that preferred cats and 100 females that preferred dogs. Now, if we take the ratio of likes cats over the total number of males, we will get roughly 70%. And if we take the ratio of likes cats for females over the total number of females, we will get roughly 60%, indicating the probabilities that we set up front. Now, if we run this cell over and over again, then we see that sometimes the number of males and the number of females is not exactly 250-250. And this is exactly what we wanted, because this represents a realistic data set much more than if we have nice round numbers. Now, of course, to see whether our code works or not, we can also change these preferences to a very extreme example. Let's say, for instance, that for males, we take the preference of cats over dogs to be 1. So 100% of males will take cats over dogs. So if we run this cell and we scroll down to our contingency table, then we indeed see that out of 246 males that were questioned, 246 liked cats over dogs. And this is also visible in our visual representation. This blue bar contains all of the male correspondence. And it is also in this way that you can change these parameters around and see whether you really understand these concepts or not. Of course, I put this back and the sum should always be equal to 1. And this is how we can use Python code to generate such an elaborate but still realistic looking data set, which allows us to tune the correlation between these two categorical values. The challenge is to use this generated data set to now quantify this correlation between categorical variables. And that is exactly what we will do in the next and the last lesson of this chapter.